Hi, today we're going to study arithmetic sequences, and we're trying to find a way to add them together. Okay, so lots of numbers, and how to add them together. Okay, so let's begin with the first problem. Then we try to find a general formula. Then we use the formula, or if we don't want to use the formula, we can repeat the same idea to solve the problem. So David read a book. Okay, on the first day, he read 8 pages. And he read 2 more pages than the previous day each time. On the last day, he read 24 pages. How many pages did David read? Okay, so this is a problem, right? So let's write down. Maybe you can list all of them. If you can list all of them, you're fine. Then it's easy to solve the problem, right? So 8, second day 10, and the 12, and the 14, and 16, 18, 20, 22, 24. Stop there, right? So this, how many, many numbers here. How many numbers here total? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers. We want to add them together. Okay, how to add them together? Okay, how to add them together? Somebody got 144, somebody got 128. Oh, so it's not, that means not easy to find the sum, right? Okay. So to add them together, you cannot, if you have a calculator, of course you can do one by one. But suppose I have 100 numbers, then it's not easy to do this way, right? So what I'm going to do is, the standard method is I reverse the order, okay? So I begin with 8 here, then 10, then 12, and 14, 16, right? And then 18, 20, 22, 24. So what I'm going to do is I add those 2 sequences together. Okay, if I add them together each time, then reorder them, add those 2 numbers together. Okay, so what I got here is, and what I got here is 32, 32, 32. Every time you get 32. Okay. So if all the numbers are 32 in this sequence, it's easy to add them together, right? So we reorder the numbers. And if I add them together, you get 32 times 9 numbers here. Just do the multiplication. You can get the sum, okay? But 32 times 9 is the sum of those 2 sequences, the numbers in these 2 sequences. But those 2 sequences are identical. I just reverse the order, right? So that means if we want to find the sum of the numbers in one sequence, I just needed to divide this sum by 2, right? Clear? Let me repeat again. So you have a sequence from 8, 10, 12, 14, 16, 18, 20, 22, 24. I want to add them together, but I cannot do that directly. It's too complicated. So I reverse the order, right? And line up. Then, and regroup the numbers in the sum. Otherwise, you have a total, how many terms, right? Total is 18 terms, 2 times 9. But I find a pair of the numbers, add them together first, right? Then I got 32 plus 32 plus 32. Then multiply by 9, then I got the total sum. But that is double the sum of the original sequence. So I have to divide by 2. Okay? And then if you do this, then you get 144. Okay? This is how do we get the idea. Now, you notice that, okay, 8 plus 24 is the sum of the first term plus and the last term, right? Then 9 is the number of the terms. right? 9 is the number of term. 32 is the sum of the first term and the last term, okay? Or you can also say the second term and the term before the last term. That's okay, the same number, right? So you will see that this is going to be the same, you know, right? So sum of the first term and the last term. So we guess we should have this formula in general. So the formula says that the first term and the last term, add them together, divide by, and then multiply by the number of the terms, which is 9, and divide by 2. So you conclude a formula, okay? Once you have a formula, then it's easy to solve the problem. So let's look at the following problem, okay? And they have a 1, 3, 5, 7, 9, 11, 13, 15, 17. We want to add them together, right? We want to add them together, okay? How to do that? Well, forget the formula, right? We do this way. I reverse the order, right? 1, 3, 5, 7, 9, 11, 13, 15, 17. I add them together, and then the first term, last term is by 18. And then you have this, like 18. So here's 18. So add them together, you get 18 times how many terms do you have here? You still have, you have to figure out how many other terms, right? It's 9. So you say it's 9, okay? So you multiply by 9, okay? Then the answer, the sum, is going to be 18 times 9 divided by 2, right? Its answer is 81. But if you use a formula, okay? If you use a formula, you don't need to repeat the idea over again. You know, you just the first term plus last term multiply the number of the term divided by 2. Okay, so okay, you don't need to repeat the same idea and over again. Okay, right? For example, yeah, yeah, we have another example. Okay. That if you are given 11 plus 14 plus 17 plus 20 plus 23, 26, and 29. Now, this is called arithmetic sequence because it's increased every time by 3. Okay, add 3 to 11, you get 14, add 3 to 14, you get 17, add 3 to 17, you get 20, right? So this is an arithmetic sequence. By above formula, it will be the sum of the first term and the last term. Okay, now the question is how many terms here, but you don't have so many terms, so you just count, right? 1, 2, 3, 4, 5, 6, 7. So multiply 7, right? Then you have to divide by 2, okay? If you use a formula, and you get 40 times 7 divided by 2, you get 20 times 7, you get 140. Okay? Okay? Yeah, using the formula, you can easily get the answer. Okay? So I can give you another one. You know, I begin with 7, right? 10, 13, 16, 19, 22, right? 25, 28, okay? And how to add this together, okay? Can you do this? All right, only one gave me the answers. Okay, so how do you do that? You can use above formula, 7 plus 28, and the times the number of terms. 1, 2, 3, 4, 5, 6, 7, 8, right? You have the term, 8 terms, and then divide by 2, okay? Divide by 2, okay? Then you use a calculate, you know, if you don't want to calculate, that's fine, and time 28, right? Times, times 8, divided by 2, okay, 140. So 140 is the answer. Now, I think the most difficult part is to count how many terms there. Okay, so given arithmetic sequence, okay, so the sequence begin with a 7, right, and the 10 and the 13, but I know the last term is going to be 154. Okay, I already told you this is the arithmetic sequence. Okay, how many terms are there? Okay, how many terms are there? Yeah, how do you figure out how many terms are there? You know, because then what is a sum? That's the first question. Second question, if you solve the first problem, if you answer the first question, right? What is a sum? Okay, now because this is a long list, it's harder to find out the number of terms, right? Yeah. So how to do that, the number of terms, that's also formula there, but let's do this way. It is you know, every time it's increased by 3, right? So let's think about that. The 10, 13, so it's increased by 3, and then the 154, it's increased by 3. Okay, nice. Okay, so there are a couple ways to figure out the number of terms. Okay, the term before 7, it's not included. The term before 7 is going to be it's going to be 10, 3, 7 minus 3, it's a 4, right? But 4 is not included here, so it's a 4. Okay, the 4 plus 7, right? The 4 plus 3 is going to be 7. So the idea is that you can do the subtraction, then multiply, divide by, you know, the standard formula is the difference of the two terms, okay? The difference of those two terms divided by 3, and you have to add 1, okay? So why, let me explain to you why this is true, okay? So you can, why this end up with like the difference of this 3 and the multiply. So the answer is going to be 50, okay? Now, why is the difference? And you see how many terms you are going to get, right? Right? Every time you add 3. So the last term, 154, is 7 plus 3 times the number of the terms. No, this is not just exact number of terms because you add 1 less of the number of the terms. Okay? So using this equation, you can get, then this is going to be 154 minus 7 divided by 3. But that number you will get is just 1 less than total number of the terms. Okay, that's why you have to add 1. Okay, because every time you add add 3, so 7 plus 3 times the number of the additions you're going to do, right? So that's why you, that's why you get as the numbers of terms. You have to divide by 3, okay? So the difference of two terms, divide by 3 plus 1. Okay, so that's you get. Once you get that, then the sum, and then it's going to be 7 plus 154 times 50 and divide by 2. Okay, then you get the answer. Okay, then you get the answer. Okay, so that's going to be 7 plus 154. Okay, and then multiply by, yeah, it's going to be 4,025. Okay, 4,025. So you can try to figure out how to count the numbers of terms. Okay, my suggestion to you, you have the standard formula is the difference between the last term and the first term divided by the number each time you add it to the previous term. Okay, but you still have to add the 1. Now, how to get this formula? The idea is from here, this side. Okay, but the difference divided by 3 gives us a number of the terms minus 1. Okay, but let's take a look at the following problem. Okay, then yeah, that's application. Okay, there are 10 lockers on a table and 10 keys, 1 for each lock. If all keys are messed up, what is the maximum number of the failures in order to match the keys with the lockers? Match all the keys for them. So you have a 10 locks and the 10 keys. Okay, 10 lock. Okay. Okay, and the 10 keys. Okay, you want to try, right? One by one. You want to try one by one. Okay. So Eric, I don't know what you're typing. So please don't type nonsense there on the screen. So you have to give me the answers. Okay. 99 is wrong. You don't need so many times to match all the keys with the locks. Okay, don't try. Okay, you have to find a reason. Okay. All right, so what do you do? Right, so I use the first key, right? And then try one by one. Right? So the first key, how many times do you need to try? How many failures? You don't need 10, just 9. The maximum number of the failures is 9 because after you try 9, right? You know you get match key. So for example, you try the first one, okay, doesn't work. The second one doesn't work. The maximum number of the locks you can try, right, is going to be 9 because the last one definitely works. You don't even try because you're told that you have 10 keys and 10 locks that they're match, you know, in some way. It's messed up, right? So 9 times. So then you put the key and the lock away. So only 9 keys, 9 locks left. The second key, right? Use a second key, pick up a second key, right? Then you only need to try 8 locks. The maximum number of locks you can try is 8. Then you figure it out, right? And so on. Okay. So the 10th key, you don't even try, right? It's there. So 9th key, you just try once because you have 2 locks, 2 keys here. So you pick up a key, try one. Okay, if it's open, that's fine. The worst case is you couldn't open it. Then the key must match with another one. So just only try once. So this is 0, okay? So the sum, okay, the total will be the maximum number of of variables is going to be 9 plus 8 plus 7 plus 6 and plus 5 plus 4 plus 3 plus 2 plus 1. You just need to know how to add them together, right? According to the above formula, it's going to be the sum of the first term and last term multiplied by the number of terms divided by 2. So that is going to be 5 times 9. 45 times. The maximum number of variables in order to match all the keys with the locks is 45. Got it? All right, it's great. Okay, let's try next one. Alan started to add the numbers, 1 plus 2 plus 3 plus 4, blah, 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 okay? The sum is 70, but he added a number twice. What is that number? So somewhere you made mistakes, okay? So do we understand the problem right now? Yeah. We get 70, just 1 plus, and just add them together, right? So please don't turn on the video and don't write on my screen. That's a rule. Otherwise, you'll be kicked out. Okay. Now we have to solve this mystery, okay? We have to solve this mystery. Now let's just assume by standard way, right? How to get to 70, right? Let's try this. 1 plus 2 plus 3, and let's assume we stop somewhere 7 or 10, okay? I'm going to start 10 here, just rough estimate. So I get the first one and the last one times number 2 divided by 2, okay? And what I got here is a 55. So 55 is much less than 70. Even I add a number twice, I never get 70, right? So you start from here. You see, even you click, use a calculator, you click on the button, even 10 twice, you only get 65, right? So can you try this, right? Then you try 11. So 11 is 1 plus 11 divided by 2 times 11, okay? That is going to be 66, okay? So then, pretty close to 70, right? 1 plus 2 plus 3 and 12, 1 plus 12 and times 12 divided by 2, okay? And that is supposed to be, let me check, okay? 13 times 6, 78. So this is larger than 78, okay? So what does that tell you? I'll give you half a minute to think about, okay? Can you figure out this number? Okay, so if you do not make any mistakes, if we add 1, 2, 3, all the way to 12, you already get 78. So definitely, yeah, just look at this gap, right? If you do not make mistakes, you add 1 all the way to 10, you get 55. Even you add as a number, okay, still not working, okay? Okay, so it's clear that I think the one in the middle, okay, this one, okay, if you add 4 somewhere, plus button 4 twice, okay, then 66 plus 4 is going to be 70, okay? So I think what he did is plus 4 twice, Okay, you add the 4 twice. It's 1 plus 2 plus 3 plus 4, then plus 4 again, and 5, 6, 7, all the way to 11. That will be 60. That will be 70. Okay, so you figured out that number. Okay, it's what we call to solve the equation mystery. But you should know how to add the numbers together, right? Assuming, you know, yeah. So that's this is how do we figure it out. Okay. All right, so now take a look at the next one. Okay, we're going to shake the hands, okay? 20 people shake hands with each other. How many hands shaking? Okay, they're not going to repeat, okay? You cannot shake the hand with yourself. You cannot shake the hand with someone twice, right? So everybody just shake hands with somebody else only once, okay? If you already shake with another person, that person cannot shake hands with you. Okay, he remembered, oh, I already shake hands with you, so not going to shake with you. So question is how many? How many hands shaking? How many hand shakes? Okay. Think about that. 11 is wrong. I got so many different answers. Alex says IDK. Okay, 9, 19, 211. Wow. Either 19 or 9, that's really big difference. Come on, you have 20 people here, cannot be 9. Obvious. Because you are, suppose you are the only one person among them, right? So you shake a hand with the rest of 19 people. That's already 19. And among those 19 people, they also shake hands with each other. Come on. Right? Don't, Alex, don't guess, okay? You have to do computation. It's not in circle in a line. I just want to people shake hands with each other. All right, so let's do the problem. Okay, what I'm going to do is you have to use a draw picture, right? What I'm going to do is like this. I'm going to line up. Okay, 1, 2, 3. Here's 20, and also, yeah, this is the way. So how do you do that? The first person is going to shake hands with somebody else. Okay, so so this is going to be 1, 2, 3, 4, all the way to 20. So how many for the first person? I have 9 hands shaking, right? Handshakes, okay, 19 times. And then for the second person, come on, he's not going to shake. He's not going to shake hand with the first person because he already did it. So he can only go forward. Okay, 2, 3, 2, 4, blah blah blah, 220. So the second person can only have 18 handshakes. Okay, and so on, right? And the 19th person only have 1 handshake with 20. Okay, you can only go forward, cannot go backward because those 2 people already shake hands, shake the hands. So total will be 19 plus 18 plus 17 plus 16 all the way to 2. Okay, okay, got it. So the answer will be the sum of the first term and last term multiplied by 19 and then divide by 2. Okay, so it's going to be 10 times 19 is 190. 190, Derek. 190. Okay? Yeah. So that's way how to do that, right? Let me repeat again. You line up those 20 people, right? Then you start with the first one. So that's the first one to shake hands with everybody. After he's done, he's out, right? So he shook it 19 times. He's out because people cannot shake hands back with him, right? So you remove him. Then the second person to do that, right? Do the same way. So you get an 18 times. So that guarantee everybody shake hands with each other only once. Got it? I hope you understand this, okay? So let's do the next problem. Similar problem. Each family member called each other members in the family. Total 36 calls were made. How many family members are in this family? So this is inverse problem, okay? This is the inverse problem, yeah. Eric King, please turn on the video. Please do. Okay. Thank you. So each family member call each other. So we on the record, okay, there are 36 calls made. Okay. So the question is how many members in the family? Of course you just guess and try, okay? You guess and try, but you get the general idea, how do we get 36? How do we get 36? Right? And let's try this, right? So we guess the idea is if you have we don't want solve equations here. So we guess and try, okay? So you have let's just look at the three members only. If there are only three members, okay? If there are only three members, just like a handshaking, right? I think we already did the 199, so we should have less than 19 in a bigger family, okay? So if I only have 1, 2, 3, okay? So what you get here is 1, 2, 2. So only 3, right? So in that case, only 3. So 2 plus 1 equals 3. If you have 4 members, 1, 2, 3, 1, 2, and right. So that would be 3 plus 2 plus 1, which is 6. So we can get this number getting larger and larger quickly. Okay, right? And I have to probably jump. I don't want to, it's close to be slow. Let's try 7. Okay, if I try 7, I will get 1, 2, 3, right, all the way to 7. So it's a 6 plus 5 plus 4 plus 3 plus 2 plus 1. So that's going to be 6 plus 1 times 6 divided by 2. Okay, and that is going to be 21. All right, 21, right? It's getting close to 36, as you can see that, right? Okay, so 1, 2, all the way to 8. So you will get 7 plus 6 plus 5 plus 4 all the way to 1, right? So 7 plus 1 multiplied by 7 divided by 2 and 28. I think the last one works. Okay, then you have a 1, 2, 9 members. Okay, so 9 members, you make a phone calls, okay, to each other, just like a handshake. Okay, so you get 8 plus 7 plus 6 all the way to 1, so it's 8 plus 1 times 8 divided by 2, okay, and the 36. Yeah, 4 times 9 is 36. So there are 9 members in the family. There are 9 members in the family. Okay. So you first of all, you make a quick conjecture, so you don't need to repeat so many times. You can sometimes, usually, yeah, you begin with 6 or 7, maybe, right? But the idea is similar. Okay. Now, you can solve the equations, but that is an advanced math class. Suppose I give you a very large number, it's not easy to figure it out. Okay? Then you can't, yeah, then you solve the equation like if k members, k minus 1 times k is going to be divided by 2, and that's going to be 36. You have to solve that equation. So that's not easy to get. Okay. So it's 9. Yeah. Okay, k is going to be 9. All right, so let's take a look at the next problem. Okay, Sophia was on the springboard. She memorized 6 new words on the first day, and afterwards, on each day, she memorized n more words than the previous day. So we don't know. Just the n is a fixed number. Okay. Sophia memorized total 615 words during the 30 days. How many more words did Sophia memorize each day than the previous day? Wow. Okay. So you begin with a 6. Okay, 6. You add some number, right? Add some number. We don't know how many. This is the second number. And then you add another third, right? And so on. Okay. And then add a number. So we even don't know the last one. But total, we have a 30 days. Okay, 30 days. So the sum of all the number is going to be 6, right? The total number, add them together. Okay, the sum is going to be 615. I just want to know, I just want to know each time, each day, how many more words memorized than the previous days. Wow. Okay, so how do you solve this problem? Just assume the last day. Right, the last day you don't know. The last day is the number, right? So how do you do that, right? The last day. So the last day plus, find the sum is 6 plus the last day, right? The number of the words you memorize last day. And multiply by 30, divided by 2 should be equal to 116. Okay. So you figured out that number. Okay, you figured out that number. Figured out the number of the words memorized the last day. Okay, so you get 6 plus the number times 15 equals, right? Then you solve this, and that is going to be 41. Okay, so the sum of the words of the first day and the last day is 41, and then the last day you memorized 41 minus 6, which is 35. Okay, so you figured out the last day, you get 35 words memorized. Now the question is, how many days there? How many days you can get, and how many more words each time, so get 35, right? You got 35. Okay, can we do that? You can quickly get 35, right? It's 30 days. So only memorize one more words, I think. Okay, if you memorize, you see, how to get to the last, right? 6 plus, every time you get n words, right? Right? Every time you get n words. So 29 times this n should be equal to 35. And clearly, each time just only memorize one word, because 6 plus 29 is going to be 35. Okay, so this is a complicated problem, several steps. Step 1, I needed to know how many words memorized on the last day. Okay, and you use a formula. Okay, you use a formula. Okay, so let me repeat again. Okay, yeah, there are lots of uncertainty here. Okay, so you know that. So let me break the problem into 2 problems, right? Begin with 6 words at the beginning. Every time you memorize a certain number of words, okay, fixed number, more than before. And then the total words you memorize, total number of words you memorize, 615. How to figure out the number of the words on the 13th day, 30th day, right? And this is a formula, right? The sum of the first day and the last day multiplies the number of days divided by 2 is equal to 615. So you have to figure out that number, and then you figure out that's 35. Now once you're given 35 and you know the number of days, how to get this unknown number n, okay, which can be only 1, because 6 plus 39 is 35. Okay, this is I put a star here. This is a difficult problem. Okay. Yeah, let's try a little bit easy problem to break them into several of them. Okay. All right. So we're given an arithmetic sequence of 14 terms. I know there are 14 terms. I know the sum is 371. What is the last number? Okay, let's do this first. Okay, so yeah, we figured out what is the last number. Okay. What is the last number? Okay, we don't know how many numbers increase each time. Okay, but according to the formula, right? 7 plus the last number multiplied by 14, right? Divided by 2 is going to be 371. Can you figure out that number in the middle? All right, we have to figure out that number, right? According to the formula, the sum of the last number and the first number multiplied by the number of terms divided by 2 is equal to 371. I think 14 can be divided by 2, right? So it's a 7 plus that number times 7 is going to be 371. Got it? 14 divided by 2 is 7. Yeah. Then you have to do the both sides have to divide by 7. So divide by 7, both sides, right? So 371 divided by 7 is going to be 53. So 7 plus this unknown number is 53. Okay. Then 7 plus that number 53, that number is going to be 53 minus 7, which is 46. Okay, very clear, right? Okay, so let me do again. Okay, so formula we have to add all the terms in the arithmetic sequence will be the first term plus last term divided by 2, and then multiply by the number of terms. So the unknown number is the last number. Okay, you cannot find the last number immediately. Okay. Then you get the equation of that. Okay, another way, if you don't use a formula, you still can solve the problem. This is how do you do that, right? You line up 7 plus some number, I don't care, and plus some number, and plus the last number equal to 371. Then I reverse the order, 371. Okay, and somebody, come on, I don't know who did it. Okay, somebody right on my screen. Okay, so let's reverse the order. So it's 7 plus question mark plus this, right? Add them together. So you see that this is always the same, right? And add them together, this side will be 742. And this time is a 7 plus this unknown number, right? And so every term is the same. But how many terms here? We already know 14. So 14 terms is going to be 742. Yeah, I do have some student right on my screen, and this shouldn't do that, okay? So you have to find a place where you mark it and erase it. Okay, look at this line and who did it. Can you see that? So I'll give you a warning, okay? I'm gonna find out if we continue to do that. All right, so then you can divide both sides by 14, then you still get 53, then you figured out that number, 53 minus 7 is 46, okay? So this is the idea. So let's try next one. You already got the idea, right? So next one, given arithmetic sequence of 25 terms, if add them, the 25 terms here. So what I'm going to find is the last term, and also every time how many what number is added to the previous term to get the next one. Okay, so-called arithmetic sequence. Yeah, the arithmetic sequence. I'm going to put a question mark here. The last one I'm going to use a put a square there, right? It's 1,725. Okay. Okay, and how many terms here? We have 25 terms. Okay, and I also want to know what is the n every time you add the n, right? So what is n? So we have two questions here. So let's find out the last one. Okay, so we get 9 plus the last term multiplied by 25, and the divide by 2 is going to be 1,725. Okay. And then we multiply by 2. Okay, right? On both sides. So 1,725 times 2 is going to be 3,450. Then I have to divide both sides by 25. And I got 138. Then the last term is 138 minus 9 is 129. So there, it is 129. 129. Okay. Now the question is, what is the end? You know, you have a 25 term. The last term is going to be 129. Okay, this is going to be 129. Okay, and how many? What is the end? The end is that you have to add 24 times of this n, right? It's going to be 129. So you can figure out n. N should be equal to 5. Okay? Yeah, n should be equal to 5 because 24n equals 120 minus 9 is 120. Okay? And then n is going to be 120 divided by 24. Okay, so this is a 5. All right. So I'm going to ask you to do the next one. Okay. Try this. Given an arithmetic sequence of 14 terms, you have 14 terms. What is the second term? What is the second term? You are given the last term also. Okay. What is the second term? Okay. Think about that. Okay. Hey, anyone? We have fractions. Are you kidding? All right. So so the idea is you don't know what number you're going to get, right? We don't need to know the sum. So the next number, just add the n, right? And then if we add an n, you get 89. Okay. What's the relationship between them? Remember, the number of terms is a difference, right? It's difference divided by 14, and then Yeah, it's minus 11 divided by 14 plus. Yeah, let me erase this. Let me explain to you the idea first. So every time you see this is one n, then you add, that's the second term, right? The third term, you get add n again. So add n, so you get 2n, right? The third term. And keep it going, the 14th term will be n plus 13n, okay? Always one less than that. And that should be equal to 89, okay? So that's the idea, okay? So that's the idea. Then maybe there was a number problem here. So then you 89 minus 11, that would be 78, right? So 78, wow, 78 is not divisible by 13. Yes or not? N should be equal to 6. So divisible by 7. Yeah, n must be 6. Okay. But once you get the n, then you can get all the terms. Every time you add a 6 to that term. Okay. Every time you get 6. Okay. So that's why it's 11 plus 6 is going to be 17. Okay. So this is the idea, you know, if you have a, yeah, so if you have the first term, then every time you add n, the second term, you know, so on, right? And this is the last term. This is the last term, right? You add the n, add the n. So the idea is, so last term will be, see, the second term is 1n, the third term 2n, right? So it depends on how many terms do you have here, okay? So yeah, it depends on how many terms you have here, okay? Yeah, I'm going back to the audience. This is too abstract. Okay, I'm going to go back to the problem, so more specific. Yeah, let's go back to this problem. So you see the difference between those two numbers. Okay, so the difference between those two numbers. Okay, maybe we can even find the formulas again. The difference of two numbers divided by, not the numbers of terms, divided by 14 minus 1, which is 13, gives a number. Okay, gives a number. So n is going to be the last term minus the first term divided by the number of terms minus 1. Looks like that because divided by 13. All right. So you can also derive the formula by yourself. Okay. So this is how do we do that? Okay. Now in general, yeah, in general, the first term here, and then the second term by n, the third term 2n, and the last term is k minus 1. I mean, you know, it's complicated. This is last term. So this is just add, you know, if we have a k terms, but that's quite abstract if we deal with the numbers, dealing with the numbers. Okay, now let's go back to have a quick review. Okay, if we have, yeah, what is a sum? Okay, we begin with a 1, 3, 10, and the 5, all the way to 2021. Okay, let's do this. Okay. Next year is 2021. Okay. All you have to do is to figure out how many terms here. How many terms here? Question. How many terms are there? Okay, how many terms are there? Okay, can you do that? How many terms are there? Because each time is always add each time is add one, add two, right? Plus two, plus two. So 2021 is 1 plus 2 times some number, right? But that number is just one less than the total number of terms. Be careful. So that number is going to be what? It's going to be 20. It's 1010. Okay, right? 1010. Okay. So, but that's not the total number of terms. Total number of terms is going to be 11. Okay. Yeah, think about why it is. And then you can find the sum. Okay. Okay. Then you find the sum. The sum is going to be 1 plus 2021 times 1011 divided by 2. Okay. So it's going to be okay, let's see. 2021 plus 20 divided by 2. Yeah. Okay, so let's stop here, okay? And see you next time.